we're going to get into word problems soon. Okay, so first I'm just getting you to get to know sinusoidal functions, their properties, how to work them, how to graph them, and then we'll go word problem. Okay, so on page 5, we're going to switch it up a little bit. What you've been collecting when you just look at the equation those are the characteristics or properties of that resulting graph. Okay. Yesterday we learned how to get those characteristics from the function, but now we're going to switch it up. How is it from a graph? Like if you have a graph, how do you get all that? How do you get your A, B, C, D from a graph? Okay, and the period, I should say. A, B, C, D, and the period from the graph. So here it is. To get your period, you go x max 2 minus x max 1. What in the world am I talking about? Let's do a little sketch here. Just do a wave like this. Because we know that the period is the distance between here and here. Okay? So this would be the x. Why am I saying x max 2? Why am I using x? Because please don't use the y values of that point at the top here. You're going to use the x values, okay? This is x max 1. Okay? So you're going to subtract x max 2, x max minus x max 1. That will give you the period of this function just by looking at the graph. Similarly, or you can have two mins, right? So if you are able to only see two minimums, right, then this is x min, x min 2, this is x min 1. So you subtract them, and then you get the period out of that, okay? But we all wish it would be that easy. Sometimes they're not as gracious. What would you, yeah, of course, right? What would you do if they did this to you? All you have is this and this. What would you do there? You don't have two maxes, you don't have two mins. How much of a period do you have here? Half a period. So what you do is you take the x max here and the x min, you subtract those because you almost have to imagine the lines extend, right? You subtract them and then you multiply it by 2. This one is for partial cycle shown, okay? If you have a partial cycle, you want to resort to this method right here. Okay? Does that make sense? 3 ways to extract the wavelength, the period, out of that. Okay? It could be down the road, it's going to be a word problem. It's going to be like, how many seconds does it take for the paddle wheel to go from the top back to the top? You're like, oh, they're asking for a period, right? So it's going to take me from 2 seconds to 8 seconds. So 6 seconds. Every 6 seconds, this thing repeats itself, okay? Amplitude. How do you get the amplitude? Notice that I use y. Amplitude is top and bottom. Okay? Y max minus the midline or y min minus the midline. But my favorite is this one. This is the one that I would, this is most popular, bestseller, using Amazon language. Okay? Most popular is this one. You go y max minus y min, you find the difference between the top and the bottom, and you split that difference in half, because that's what your amplitude is. Right? If you think about it, right? If this is your max and this is the min, If we subtract them and then divide it by 2, then you'll find the amplitude, which is this, right? This is amplitude and that is amplitude. So this is the one that I would suggest you use most often. Please have that one on your study sheet. Equation of the midline. Guys, you got to pay attention. What's the only difference between this formula and that formula? Minus for amplitude, plus for midline. Okay, so please note that. Okay, there's a plus there, there's a minus there. We'll highlight that actually. There's something, I feel like there's something missing. Midline, amplitude, period. No, we're good. Okay, we're good. Now, I'm going to ask you to practice that. We'll do it together once, and then you'll figure that out. Determine the characteristics of the sinusoidal function. By min, we mean y min, okay? The lowest y value. I think you can all agree that the lowest y value is -3. I've pointed it out. It's very clear that it is -3. Y max, so when we talk about the max, just like that, we usually talk about the y value. The maximum is 7, right? The amplitude, how would you do that? Midline, how would you do that? The amplitude, I'm just going to say, I'm going to emphasize that. I always start with these two, okay? If you're reading a graph, I would always start with these. And then I find everything else based on those two, because they're the easiest to identify. Where is the top, where is the bottom? Okay? So amplitude is max minus min divided by 2. So we're going to go max, which is 7, minus, this is the minus from the formula, and min is negative, right? What's 7 minus -3? 10, right? 10 divided by 2 is 5. We're going to test that in a bit. Equation of the midline. That one is found by going max plus min divided by 2. Would you agree that the midline is the average? It's the average between the top and the bottom, right? So when you find averages, what do? You add up what you have, you divide it by the number of values. We're adding 2 values, we're dividing it by 2. So the max is 7, the min is -3, divided by 2. What's 7 plus minus? What is 2 opposite signs always turn negative? So 7 minus 3 is 4, divided by 2 is 2. Let's test this now. Let's see if this actually works out. I'm going to use pink for this one. Before we commit, midline is 2 over here. Does that look like the midline? Like if I were to cut it right here, does that look like I'm cutting it in half? I would say yes. Okay. So that's your midline. Please don't calculate it and just go with it. Actually verify to see if it makes sense. I would say it does. But one more check you want to do is, what is my amplitude? It's 5, right? Which means it should take you from here to the top, should take you 5 units. Let's check that. We are at 2 here, right? This is the 2 line. If we go up 5, 1, 2, 3, 4, 5, we get to 7, right? If we go from the midline and go down 5, 1, 2, 3, 4, 5, we do get to -3. Like from 2 minus 5, we do get to -3. So that's something you want to check. That is the amplitude. You should see the same distance from the middle to the top and the same distance from the middle to the bottom. Why am I saying this? Because let's say your amplitude, you went 7 minus 3, that's 4 divided by 2 is 2. You get 2 for both of them. And then you look at the graph. Wait a minute, amplitude is not 2. Can't be, right? So you should be able to verify because you have a graph that that's that. How would we find the period? I will use this one, x max 2 minus x max 1. Does it matter which 2 points I pick? For which 2 maxes I pick? Does it matter? Somewhat. The only requirement for this is that they are consecutive peaks. So whether you use these 2 or you use these 2, that is up to you, okay? I'm going to use these 2 right here. So this is x max 2. How should I do this without... because you're still noobs, right? Can we do this here real quick, please? Just trust me on this one. You look back. So this is negative 6, 7. Hey. And this is 2, 7. Okay? I brought it down from my graph real quick, sketching it. So I'm going to go 2 minus negative 6. Those 2 negatives turn positive, right? So 2 plus 6 essentially. So 8 units is the period. Every 8 horizontal units, this thing will repeat itself. Let's test it. Let's start over here. If I go from 2 to 10, have I gone sideways 8 units? Yes. If I go from 2 to negative 6, like go to the left, does that look like I've traveled 8 units to the left? It should, right? So I'm just going to show you here that this is the period, and we figured out that it is 8. We also use this here, and the period is 8. Okay. Oh, you can't see that. My bad. I went from here to here 8, from here to here 8. So you figured it out just by looking at the diagram. All right, what's the domain of a sinusoidal? Is it restricted? Right? Negative infinity to positive infinity. It's not restricted. How about we write that down on our... Right? If you have negative infinity to positive infinity, you're not restricted at all. Okay? My range, however, goes from, in this case, bottom to the top, right? So negative 3 to 7. Or negative 3, 7. Restricted. Let's see. Let's see if you remember. Out of all the functions we learned about, which functions have a restricted domain? Linear never ends, right? Doesn't matter which way it's going. Cubic, it actually keeps going. Quadratic, domain, we're talking domain. Quadratic keeps going both ends. Depending, it doesn't matter which way it's pointing, it just keeps going. Logarithmic, it can't go past. Exponential has an unrestricted domain. What is restricted for an exponential though? What is, yeah, the range, the y. I'm not going to mess you up right now because let's just focus on this for now. I will try to do my best before the exam to give you one big overview of all the functions, okay? We're gonna make sure you know that, add it to your study sheet. Okay, what's the time? 1:45. I'm gonna ask you to go to pages 9 and 10. Okay, that's your homework. I'm gonna write it down on page 5. Page 9 to 10. All you need to do is look at those graphs. Look at those graphs. Come up with the max, min, midline, amplitude, period, domain, range. Listen to this part. It asks you for the equation. Don't worry about the equation just yet. We will do that tomorrow. Did you hear that? You don't have to worry about equation yet. I'll show you how to do that tomorrow. Okay? The regressions, yeah, we're going to do regressions. Regrettably,